Alright, so today we'll talk about sign numbers, which is our chapter 10 from the book. So here is the number line. So we start from 0, and as you know that if we go to the right side of the number line, we actually get the positive numbers and the number get increased. But if you go to the negative direction, number get decreased, right? We get the negative numbers. So you can think of a number line as a thermometer, because it's something like if you, let's say the temperature is 35 and the temperature gets 10 degrees warmer, meaning like positive, then you get to the right direction, the temperature becomes 45, right? And if you want to get cooler, go to the negative direction, the temperature becomes 25, something like this, right? So we'll try some operations today on number, and then the first one is called absolute value. So for an example, if we have a number with a sign in front of it, in general, if we don't have any sign, we know that is a positive number, right? But if it is a negative number, we always have a negative sign, right? But we can always find the magnitude of a number, no matter whether that is a positive or that is a negative number, just using two vertical lines like this. For an example, let's say this is a -4, but do you see there is a vertical line here and there is a vertical line here? This is called absolute value of a number. So no matter what the number is, we just write the number, meaning we get rid of the sign. That's it. Okay, so this is like an operator applied on the sign numbers. So there are many other operators which also can compare two different numbers. Some of those are called inequality sign, inequality. For an example, this one is called less than, greater than, less than equal, greater than or equal. Now remember, when we call greater than or equal, that means it can be equal or it can be greater, the first one, right? When you call lesser or equal, that means the first one can be lesser or equal to the second one. This is not equal. For an example, you tried a couple of conversions here. Let's say 5 is less than 10, right? That's like, we know it for sure. 0 is greater than -3. -5 is a smaller or equal -1. We know that -5 is not equal, right? But we can always use this symbol because we are saying equal or, right? So, either one is true. So 9 is greater or equal to 5. 3 is not equal to 2, right? Let's try a couple of, we'll try a couple of quiz questions, but before that, let's talk a little bit about the fractions with the sign numbers, with the sign. So in general, if we have the positive fraction, we don't write the sign, just like the whole numbers. But if there are two negative signs, meaning like even number of negative signs, that is actually a positive number, right? Because if we have even number of negative signs, then they get cancelled by each other, right? But if we have odd number of negative signs, for an example, one negative sign, right, either in the denominator or numerator, or we have 3 negative signs, this is still odd, right? So then, even if we cancel out, we still will be left with one negative sign. That means this number is negative. So if there are negative signs in a fraction, all we do is we just try to count whether there's positive number of negative signs or negative number of negative signs, right? Okay, let's try a couple of quiz questions here. -23, we're trying to find the absolute value, right? So right answer is B, right? Because that's the magnitude of number 23. -13.5. Again, the right answer is B. Absolute value is 13.5. Absolute value of negative 0.25. Right answer is C, right? 0.25. Positive 5.25. Absolute value is D. Absolute value means you just get rid of the sign. So that's the magnitude. So you just get D. Right answer is D, 5.25. 5 is less than C, right? 5.25. That's the only number that is, that is applied. I'm saying that is the one that is greater than 5, right? Negative 2 is less than A and C both, right? Because negative 2 is less than negative 1, and also for negative 2 is less than 0, right? So right answer is D. Negative 6 is greater than which one? No, negative 5 is greater than, negative 6 is greater than actually negative 10. See, in case of the negative numbers, the more you get to the left side, you actually get the smaller numbers. So actually negative 10 is much smaller than negative 6, right? So negative 6 is actually greater than negative 10 only. So the right answer is A. 25 is greater than, right answer is D, right? 25 is greater than 20, and at the same time 25 is greater than negative 35, right? 25 is smaller or equal. I think A and C, right? I'm sorry, A and B, right? Because A is 25 itself, so any number is equal to itself, right? I'm saying, look at the relation, is less or equal, so it's possible, right? And the absolute value of negative 25 is 25 as well. So is A and B both, so right answer is D. 25 is less than which one? It's B and C, right? So the right answer is D. Right answer is D, right? 25 is greater than negative 35, right? And negative 20. So right answer is A and B, right? So right answer is D. Okay, let's try some addition rules of sign number, meaning how we add the numbers with the sign. Now, if we add two numbers and both numbers have the same sign, then we actually add the numbers and we keep the sign. We keep the sign, be careful, we keep the sign, okay? So for an example, if you add, let's say, negative 5 and negative 7, you actually add the numbers, make it 12, but you always keep the sign. Because the sign was negative, so in the answer your sign is negative, right? So, but here are the catches. When you add the numbers, it's possible that the both numbers has different sign, right? For an example here, both number has different sign. Now if the both number has different sign, then we actually subtract the numbers. And in the answer, we keep the sign of the largest number in magnitude. So for an example, negative 6 and plus 4. Which one is larger in magnitude? It's negative 6, right? So we keep the sign of negative number. So that's why the answer is negative. We actually did a subtraction, right? That means when the signs are same, we add it, we keep the sign. When signs are different, we subtract the numbers, but we keep the sign of the larger number in magnitude. Okay? Here, Again, if the numbers are same but they are different in sign, the sum is 0, right? Because we do the subtraction then. Okay. Now, to simplify the adjacent signs, sometimes we have multiple signs. We actually make, if we have multiple positive signs, we make it just positive, right? If we have positive and negative signs, we always make it negative. For an example, let's say plus minus 3, that means it's actually negative, okay? Or minus plus is negative, meaning if we have negative and positive. But if we have negative numbers and negative signs, we just see how many negative signs we have. If we have even number of negative signs, it becomes positive, right? I'm sorry, yeah, that's it. So for an example, it says two positive negative numbers, that becomes positive, right? So again, these are some examples of change of sign, because a lot of times what we do is we just, for an example here, this is actually plus 5 minus 9. So this is like numbers with the different signs, we do the subtraction, right? So similarly, we have some more examples here, okay? Okay, let's try some quiz question. 3 plus 2 is 5, right? Right answer is B. 3 plus negative 2. It's actually 1, right? C, yeah. Because it has different sign, right? We do subtraction. Now, what is this? Negative 5. Because this, remember, you are adding and both number has the same sign, right? If both number has the same sign, you do addition, but you keep the sign. So the right answer is A. How about this? This negative makes it positive, right? So they have different sign and you are adding. So it's actually subtraction. So right answer is D, right? Right answer is D, negative 1. This is what, 5? Because negative makes it plus. So it's 3 plus 2, 5. Right answer is B. Negative 3 plus 2. Different sign, right? Negative 1, right? D. Now let's try arithmetic with several numbers, meaning addition, subtraction with several numbers. Now the best idea is if you have multiple numbers like this, more than 2, one of the idea is we still use the same idea that we did before. All we do is we start from the left side. Since these are just plus and minus, we start from the left side. We just take 2 at a time and do the addition or subtraction. Again, 2 at a time, do the addition or subtraction, which is easy for us because it's still the same technique. So for an example, what we can try is we can just try between addition and subtraction between 7 and 4, negative 4. This will be what? Subtraction, right? And we keep the sign of 7. So that makes it 3. And now we'll take care of 3 and negative 8. That makes it negative 5, right? Then again we take care of negative 5 plus 9. So we just take 2 numbers at a time and then move on. Okay? And then take next two numbers, and we'll be done. So even if you have a long sequence of number, you just take 2 numbers at a time, do the operation and keep moving on. You see what I'm saying? So it's still the same technique. Or another idea, some people like it, you can also try that. So they just get rid of all the signs, so they just add all the numbers with the positive sign. For an example, here you have 7 and 9, which have the positive sign. They add them, and they also add all the numbers with the negative sign. Add them, you do the subtraction, right? And then you keep the sign of the 16 because the 16 was larger in magnitude, right? You see what I'm saying? That's another idea, but it's up to you which one you do. I'm saying both works. Both work in the same manner. You get the same result in case. Let's try some quiz questions here. Okay? Can you try these and tell what is the answer? Let's try here. Negative 3 and negative 4, that's what? Negative 7. And then here, this is positive 7, right? So that means it's 0. Right answer is A. What is this? Negative 3 plus 4, right? So then it's what? 4, 2, 5 is 11, right? It's negative 3, so it's 9. Oh, I'm sorry. 4, 5, 2 is 11. It's negative 3 is 8, right? I'm sorry, it's 8. So right answer is D. Again, negative 3 and negative 5, those are the negative numbers. You add them, which makes it 8. And this is positive 4 and positive 2, which is 6. It's negative 2 at the answer, right? Because one in the negative number you got negative 8. In the positive ones you got positive 6. So at the end it becomes negative 8 plus 6, which makes it negative 2. Right answer is C. Any question? Okay. Let's try some multiplication and division of the sign numbers. Okay. In case of multiplication, we just disregard their signs. We just multiply, or we just divide in case of division. But once we are done, okay, with the multiplication and division, we just determine the sign based on how many negative signs you have. Remember, if you have even number of negative signs, this is actually positive sign. If you have odd number of negative signs, so you will end up with a negative number, right? So for an example, you just multiply it. So for an example, you have negative 4 and negative 9. So what you do is you actually multiply 4 and 9, disregarding their negative signs at the beginning. Okay, you get 36, and then later on you count how many negative signs you had. You actually had even number of negative signs, right? That means your answer will have a positive sign. That's what I'm saying. Same is true for the division. Okay, negative 28, let's say, divided by 7. You do the division disregarding the signs, so you get 4. And then you look at how many negative signs you had. You actually had a single negative sign, which is actually odd, right? That means your answer will have a negative sign, right? Any question? Okay. Remember, when you multiply and dividing, two things. An even number of negative signs always result in a positive number, right? An odd number of negative signs, again, always result in a negative signs, negative answer. Okay. So sometimes you may have parentheses, but you can always treat parentheses as multiplication. Okay. But we always use some parentheses sometimes for our own clarity, right? Let's say we use these instead of these, because we always use some sort of parentheses. Because now we have multiple operators, right? Plus, minus, division, multiplication, everything together. So that's why with the number and sign we use some parentheses when you do the math in paper, right? Okay, negative 3 times 4. Negative 12, right? It's one single negative sign, which is odd, right? Odd number of negative signs. Right answer is C. Negative 3. So right answer is C again. 20 by 5 is 4. How many negative signs do you have? 3, which is odd. So result is negative 4, right? So right answer is B. Right answer is 4, right? So it's A. Right answer is A, right? Okay. How do you solve word problems with the sign number? If we have any word problem, we try to determine the sign of the numbers, or designate the positive and negative and write the numbers including the sign. Okay. And then we determine the mathematical operations. Maybe we have to do addition, subtraction, or multiplication or division, and then we do the math. And we make sure we always use the signs with the number, because those are sign numbers. And always we use the units, just like the any other engineering problem. Okay. For an example, a checking account had a balance of 1,000 at the end of July. In August, there was an electronic deposit of $500 on August 1st. Checks were written for $700, $150. What's the balance at the end of the August? Now you see here, all the deposits is like actually addition, and all the checks are subtraction, right? So we use their signs. So this is a deposit, and then another deposit here, and then these are subtractions, right? Now we add all the positive numbers, which makes it 1,500. Add all the negative numbers, which is 850, and then we do the subtraction. And at the end, we keep the positive sign because the deposit is more than checks, right? Subtraction. So it's addition. I'm saying we keep the positive sign. So the balance is 650 at the end of the month of August, right? So we kept the sign. We also try some more operators with the sign numbers. One is called powers, right? So for an example, power of a square, right, is what? 9, because it's a square means you are multiplying 3 times 3, right? And power of cube meaning you are multiplying 3 times the same number. Similarly, you can do what? Power of 5, that means you are multiplying 2 times 2 times 2 times 2 times 2, right? That means 5, 2 you are multiplying. So in case of the power, let's say 2 to the power 5, we call 2 is the base, and we call 5 is the exponent, right? We also do an operation called root, okay? That is a number which is, so you actually have to find a number which is multiplied to get that. For an example, let's say if you have to find a root of 25, that means you'll be finding a number which is multiplied by itself to get 25, which is 5, right? So that's how we get the root. Root is also sometimes treated as to the power half or to the power 0.5. And we always write plus minus in front of root. There is a reason, because think about this. If you have 5 times 5, you get 25. At the same time, if you have negative 5 times negative 5, you still get 25, right? So that means root will be always plus and minus. 2 numbers. So that's why we use a sign. I'm saying that means like plus 5 and minus 5 both. So we can also find the cubic root. Now the cubic root means, let's say you have 27, and I said, can you find a number which multiplied 3 times by itself to get 27? And that's 3, right? Because if you multiply 3 times 3 times 3, you get 27. But don't forget that root and cubic root of any number may not be whole number. Most of the time it is actually a fraction. We actually pick some numbers which are easy to find, right? I'm saying easy to find the cubic root and easy to find the square root, but we can use our calculator to find it, right? Okay. Again, I think we know how to get the power, right? Let's say if something is a square, that means you multiply it by 2 times. If it is to the power 3 times, right? And something we need to be careful when we are using a sign number, right? For an example, this number here is actually negative 2 to the power cube. That means negative is included in the power. But look at this one here. Negative sign is not included in the power. So there are differences between this and this, okay? So that means the exponent here is applied to the negative sign, but the exponent here is not applied to the negative sign. Now how does it make it different? For an example, look at this example here. Negative 2 whole square, because the negative sign is included in the power, is applied to the power. So you are actually multiplying negative 2 times negative 2, which becomes positive 4, right? But if we don't have the parentheses, then a square is actually applied to only 2, not on the negative sign. So negative sign remains same, but you multiply 2 times 2, make it 4, which is negative 4. You see what I'm saying? So look at the difference here. You see the difference in the sign? So be careful. If there is no parenthesis, so the square or power is not applied on the negative sign, okay? Similarly here, let's say 7, this is a power of -7, right? So -7 times -7, 49. But here is -2 to the power cube, so you multiply -2 times -2 times -2. You get add, but there are odd numbers of negative sign, right? 3 negative signs, so that's why you keep the negative sign. Any question here? Again, it's exactly the same thing. If you have odd number of negative signs, you keep the negative sign, right? But here you have even number of negative signs, so that means it's positive. Let's try some more example, but this is very interesting because anything to the power 0 is always 1, no matter what that is. No matter what that is. You see here, -7 to the power 0 is 1. Anything to the power 0 is 1. Anything. Even it can be 1,000,000 to the power 0 is still 1. Okay? So anything to the power 0 is 1. So, you know, and anything to the power 1 is the number itself. Okay. Interestingly, sometimes the power can be negative, meaning the exponent can be negative. Okay? We know that the base is negative. You have already seen it, right? But the exponent can be negative. Now what happens if the exponent is negative? Now for an example, let's see here. If the exponent is negative, we actually take the reciprocal of that number and then make the power positive. You see what I'm saying? For an example, this is what? 5 to the power -2. That actually means 1 over 5 to the power +2. You see what I'm saying? And then we know the rest, right? So anytime, for an example, if the power is negative, then we actually do 1 over the same thing with the power positive. And we know the rest, right? So be careful. If the exponent is negative, it's actually 1 over the same thing with the positive power. Okay? It's actually a reciprocal. That means the whole thing becomes a denominator. Okay? And then the same exponent but the positive base. Positive exponent, same, yeah. Let's try some quiz questions here. 4 square, 4 times 4, right? 16. Right answer is B. -4 square. -16, right? Because it's not, square is not applied on negative sign, so you still have one negative sign. So right answer is A. -4 whole square is actually -4 times -4, which is 16, right? Because there are 2 negative signs right now. So right answer is B. Square root of 9. Right answer is D, right? Because remember it's plus minus 3. Because if you multiply -3 times -3, it becomes 9, right? So right answer is both A and B. Any question? Okay, cubic 8 to the power 1 over 3. Is actually cubic root of 8, right? So that means you have to find a number which multiplied by itself 3 times to get 8. What is that number? It's 2, right? If you multiply 2 times 2 times 2, what do you get? 8, right? So right answer is A. Cubic root of -8. So you multiply, so you get a number which you multiply 3 times to get -8. Do you see anything there in the list? -2, right? So right answer is B. If you multiply -2 times -2 times -2, that becomes -8, right? So right answer is B. Now, again, it's pretty much the previous stuff, but a lot of times what we do is when we have things like these, we try to group it, meaning, let's say we take care of the things we have the inside the parentheses, right? For example, 6 minus 9 is +3, right? 5 minus 3 is +2, okay? And then we write the answer, again, adding and subtracting, okay? Now, if the problem contains more than one set of parentheses, we always take care of the innermost first, innermost. So this is the innermost, right? We took care of that first. And then we remove the parentheses, negative makes it positive, then we again take care of this, okay? Because we always take care of the parentheses first. 9 plus 5 is 14, and then at last we are doing 6 minus 14, which makes it -8. We have more examples here. So for an example here, we do the innermost first, right? For an example, this one first, which makes it -5, and then this one, -8, and then we remove the parentheses, so negative here makes it positive. Positive negative here makes it negative. Then we again take care of these two, which may be like 9 plus 8 is 14, minus 8, which makes it 6. 6 times 6, 36. So don't forget, we always take care of the innermost parentheses first, okay? Okay, here we did the parentheses first, but don't forget this negative and this negative makes it positive, right? This is the negative signs at the outside, right? So if we have a negative side written outside of the parentheses, can be removed by changing the side inside. So for an example, if you have these, you can just remove the parentheses and change the sign. So plus 9 becomes -9, plus 4 becomes, I'm sorry, -4 becomes +4, -3 becomes, I'm saying +3 becomes -3, and then we know the rest, right? You multiply these two, becomes 30, and then it's 34 here, and then this is -9, that becomes 25. So parentheses used to separate a negative sign from an arithmetic sign do not need to be removed until they are no longer needed for clarity. I'm saying you don't have to remove these until, you know. So, you know, you can just, this is just a negative number inside the parentheses, so there is no operation here, so you don't have to remove it until you are done. So at the very last step, right? So here are some examples from the book that how we tried some operations here. For an example, this one, if you see here, we tried to take care of these parentheses here. 24, -2 times -14, which makes it -28. And then here 7 plus 7, which is 14 here. Now you do the division, which makes it -2, and it becomes -4. And then 4 times 2 is 8. There is a negative sign. It's an odd number of negative sign, so we keep the sign. Now, before we move on to some complicated ones, let's talk this one. This is the important part, because now we have negative numbers and also we have all the operators together, right? We might have powers, we might have roots, we might have addition, subtraction, multiplication, division in the whole arithmetic, you know, equation, right, or expressions. Now the point is, which one we take care first? The idea is this: you always take care of the parentheses first, innermost one, right? Now inside the parentheses, if you don't have parentheses, you don't have to take care of the parentheses. But if you have the parentheses, inside the parentheses, you always take care of powers and roots first, because they have the highest precedence. Then you take care of multiplication and division. And at the very last, you take care of addition and subtraction. This is called order of operations, meaning which operators has the highest preference, okay? Because you probably might have something, complex like this, okay? So which has many different operators, then you really have to see which one you do first. But let's try some quiz questions to understand it a little bit better, okay? Let's say here, we have multiplications, right? We have divisions, we have subtraction as well. How do you start? Let me show you here. So for an example, what we do is this. We first do the multiplication here, which is actually 3 times 2, 6. And then, remember, multiplication and division precedes a subtraction, right? So then we also do the division, which makes it 5, and at the very end, we do the subtraction. So the right answer is 1. Can you try these and then we'll look at how to solve it? Remember, you have subtraction, addition, and subtraction, multiplication, and division, right? Which might be the right answer? So which one is the right answer here? So which one? C? Yeah, C is the right answer. Let's see here. So we first try the multiplication, right? We first do the multiplication to get 30, and then we do the division, 30 by 5, which makes it 6, and subtraction is at the very end, right? Which makes it -4. Any question? Let's look at another example. We have parentheses now, right? We also have additions. We also have multiplication, subtraction. But remember, we always take care of parentheses first, right? So how do we start? We first do this, right? This is 10 minus 6, which is 4, right? So we wrote the 4, and then inside the second parenthesis, we have taken care of multiplication first, right? Because we have to do the multiplication, which is 2 times 4 is 8. Now we have 8 here, then still we have to take care of this parenthesis first. 10 minus 8, which is 2. Now we have division and multiplication. Remember, in case of division and multiplication, we know that they both have the same precedence, right? So we take care of the one which we have at the left side first. So for an example, in the left side we have division, right? So we do the division first, we get 2, and then multiplication at the end to get 6. Now you might have wondered, you have seen some of the subtractions is done earlier, right? Because those are inside the parentheses. For an example, this one, right? We did it because this was inside the parentheses. Remember, we said take care of the parentheses first. And inside the parentheses, we only had one subtraction. So right answer is 6 here. Any question? Then let's go to the homework section, okay, and try the homeworks for chapter 10.